Hi viewers, today's topic is finite differences. Finite differences is a part of numerical method. In this method, we are going to discuss about finite differences, difference table and difference and other operators. For finite differences, suppose that y is a function of x. That means variable x is independent and that depends upon rule of f, and we get the result y is tabulated as follows. X equal to x0, x1, x2, x3 up to xn, and value of y is, for x equal to x0, put fx0, that means y equal to y0, y1, y2, y3 and yn, where xn equal to x0 plus nh and n is equal to 0, 1, 2, 3, 4 up to n. Put n equal to 0 in this equation, xn equal to x0, we get x1 equal to x0 plus 0 into h. x0 is, that means x0 equal to x0. Put n equal to 1, that means x1 equal to x0 plus 1 into h, that means x0 plus h. And x2 equal to, put n equal to 2, then x2 equal to x0 plus 2h. And in this way, we get xn equal to x0 plus nh. That means difference in x conjugative term is fixed and step is h, and entry is y0, y1, y2, y3, yn. We want to difference of y1 minus y0 or y2 minus y1, or terms in y, we get difference y. To determine the value of y for some intermediate value of x, we use difference table and difference operator. That means there is some point between x0 and x1, and for this point, what is the value of y? x1 and x2, there are many points, and what is the value of y for this point? So we use difference operator and difference table. Now, difference operator and difference table, we need differences. There is finite difference. Here, y1 minus y0 is a finite number and its difference is finite difference. For x1 minus x0, infinite limiting difference. When x1 tends to x0, then the value of y is called limiting difference. Here we discuss only finite differences. So first, what is difference table and difference operator, we discuss. Now, difference table, we make value of x value of y, first order difference, second order difference, suppose value of x is x0, x1, x2, x3. Its corresponding value of y is y0, y1, y2, y3. First order difference, that means y1 minus y0 written in middle position of these two quantities, that means we write y1 minus y0. First order difference in y2 and y1, this is we rewrite is a y1 minus y2 minus y1. And in this case, first order difference is y3 minus y2. Second order difference, that means y2 minus y1 minus y1 minus y0, that means y2 minus y1 y1 2y1 plus y0. And in this case, y3 minus y2 minus y2, that means 2y2 plus y1. Third order difference. This quantity y3 minus 2y2 plus y1 minus this quantity, this becomes y3 minus 3y2 plus 3y1 minus y0. Thus, in successive terms are doing in such a way. This is difference table. Now, we make, there are 5 difference operator. First difference operator is called delta, capital delta. This is called forward difference operator. And delta y, suppose in general term delta yn equal to yn plus 1 minus yn. First difference. So in this case, y1 delta y1 delta y0 is y1 minus y0. Forward of y0, that means y1 minus y0 is delta y0. So we y1 minus y0 is here delta y0. Similarly, y2 minus y1 becomes delta y1 and y3 minus y2 becomes delta y2. For the second order differences, term is delta square yn equal to delta yn plus 1 minus delta yn. So delta y1 minus delta y0, this is equal to y2 minus 2y1 plus y0. So we delete this portion and write delta square y0. Here difference of delta y2 minus delta y1, y3 minus 2y2 plus y1 becomes delta square y1. And similarly, this is equal to delta square y1 minus delta square y0, that is y3 minus 3y2 plus 3y1 equal to y0. So it becomes delta q y0. This is forward difference operator. We select this operator in this difference table. Capital Del is called backward difference operator. Backward difference operator. Here y1 minus y0 is back of y1, so it is written as del y1. Capital Del is a backward difference operator. y1 minus y0 is back of y1, that means del y1. And y2 minus y1 minus y1 minus y0 equal to del y2 minus del y1 equal to del square y2 is a second order difference, backward difference operator. So we can write here y1 minus y0 is del y1, so in this place we write del y1. y2 minus y1 is back of y2, so here we write del y2, and in this place del y3. Similarly, y2 minus 2y1 plus y0, here we write del square y2, and in this place write del square y3, and this is back of y3, back is y2, so here third order difference is del q y3. Its leading term is y3, which controls the whole table. Now, again, small delta is called central difference operator. Now, delta yn is here. Yn plus half minus yn minus half. That means yn is the center of n plus half and n minus half. So, y1 minus y0 is, its center is 1 plus 0 by 2, that means half. So, here we write del y half. 1 and 2, center is half. Central difference operator is del y. 1 plus 2 by 2, that means 3 by 2 or 1.5. And this is equal to 2 and 3, 2.5 or delta y 5 by 2. Here, second order differences. So, second order differences, that means this is equal to del square y. Center of 3 by 2 and half, that means 1.5 and 0.5 is 1. 5 by 2 and 3 by 2, that means 2.5 and 1.5, center is average, that means 2.5 plus 1.5 by 2 is 2. So here we write del square y 2. Again, third order difference, so this quantity is del q y 2 and a half, center is 3 by 2. This is delta, small delta is a central difference operator. Here middle portion is 3 by 2, it is the leading term. 1 and 2, this is middle of, the middle term is 3 by 2. Delta is forward difference operator. Del backward difference operator. Small delta central difference operator. And another two operator is mu is averaging operator, and one more is E is shift operator. First case, when delta apply on yn, this is equal to yn plus 1 minus yn. Del yn is equal to yn minus 1 back of yn. Small delta yn is center, where yn is the center, that means this is equal to yn plus half minus yn minus half. Center of n minus half and n plus half. And another two operator is mu averaging operator and E is shift operator. Mu yn is averaging operator, that means yn plus half plus yn minus half by 2, and E is a shift operator, yn equal to yn, nth place is shifted by n, yn plus n. Again, y is term of fx and x1 is x plus h, then delta y1, delta y0 is y1 minus y0, this is equal to fx1 minus fx0, or in general delta fx equal to fx plus h minus fx, and y1 minus y0 is equal to forward of y0, that means delta y0 is equal to del y1 is equal to center of y1 y0 is del y half. Value is same, but here symbol is changed. In the next video, we are discussing about the different type of operator and relation. If you like this video, please subscribe, like and share. Don't forget to turn on bell icon to get the latest videos. Thank you for watching Math Tutorials for All. For any suggestion, please do comment on the video.